Howdy everyone, I'm Armon Montazeri. I'm in Math 151, Section 505 with J.D. Kim, and today I will demonstrate an optimization problem for the audience, which in this case is Math 151 students, and then I will at the end show you what the solution means in terms of the whole problem. So without further ado, let's get started. Alright everyone, first I'm going to read you guys the problem before we start solving it. So the U.S. Post Office will accept a box for shipment only if the sum of the height and girth, so the distance around the bottom, is at most 108 inches. Find the dimensions of the largest acceptable box with square top and bottom. So with any optimization problem, it is always best to start by drawing the diagram. So first, the problem tells you that there's a square top and bottom, so right off the bat, you know that it's going to have a cubic-like structure. That's a hint that they give you. So we're first going to draw this box and then label its dimensions with variables, and in my case I will use x and then h for the height, so the x will resemble the length and the width of the base, and then this h is the height of the box. So next we want to state the volume, the formula of the volume of the box, which is x squared times h. But wait, there's more information that they're giving us. They say that the sum of the height and the girth is at most 108 inches. So we need to include that formula in this problem as well. So you have 2 times 2x, which is the sum of the top and the bottom, plus the height, which is equal to 108 inches. So let's simplify this further. So you have 4x plus h equals 108 inches. So now you want to plug this back into the volume equation to plug it in for h in terms of x. So you have h is equal to 108 minus 4x. So now you have volume is equal to x squared times 108 minus 4x. So then this is equal to 108x squared minus 4x cubed. So now you want to find the derivative and solve for its critical numbers. So v prime of x as a result, and we're going to be using the power law for this, the power rule. So you have 216x minus 12x squared. So now we're going to factor this to solve for the x values. So we can take out a 12x, this will give us 18 minus x, so 12x times 18 is 216x, and then 12x minus x is negative 12x squared, so we did that correctly. X is equal to 0 and 18, but we can omit the 0 because you can't have 0 as a unit for dimensions. So now you have 18, and then given 18, you can plug that back in to this equation and solve for the height. So you have 4 times 18 plus h equals 108 inches, and then 18 times 4 is 72. 72 plus h is equal to 108 inches. So the height is equal to 108 minus 72, which equals 36 inches. Last thing, to test if this is correct, we can use the second derivative test to truly identify whether this will maximize its dimensions or not. So given our first derivative equation, we will solve its second derivative, which will give you 216 minus 24x. And then when you plug in 18, this will give you a negative number, which means that it will be concave down, which means that it will have a max. So we are good for that. So our dimensions for this problem are 18 inches by 18 inches by 36 inches. So this means that the dimensions to maximize this box with a square top and bottom is 18 inches by 18 inches by 36 inches. Thank you guys, And as always, gegen.